is equal 2 in or you can write NC exponential. Okay, here what is the answer? Exponential. And next what is here? Minus of EC minus EF by KT. EC minus EF by KT. Okay. And next here NC is equal, this is effective density of electrons, that is 2 into 2 pi M E M E KT 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 by H square to the power of 3 by 2. This is effective density of electrons. Okay, effective density of electrons. Okay, so if you write here for a effective density of holes, you can write NV into exponential. What is here? What is you will have here? Exponential of what?
EV minus EF.
Yeah, EV minus EF, or you can write EF minus, I am taking EF minus
Minus of EF minus EV.
by KT, because see why we are taking minus, you can multiply minus also, but if you take here this is conduction band, right? Conduction band, and this is valence band. Okay, EF is suppose middle. If you take EF is middle. Okay, this is EC level, lowest energy in the conduction band. EV is the highest energy in the valence band. Okay, so EF is higher than the EV. That's why in holes, in case of holes, I have written EF minus EV. So in case of electrons, EC is higher compared to EF. That's why we have written EC minus EF. Okay, this is easy to recall it. Easy to means write the expression. Okay, whether you no need of any confusion. Just EC is highest energy, so EC minus EF. Okay, here also EF is highest energy compared to EV, so EF minus EV. So here minus is common to both terms. Okay, this is simple expression. Okay, so here NV is equal same. This is effective density of holes. You can write 2 into 2 pi. Here MH effective mass of holes and KT and H square here 3 by 2. Okay, these things we have derived in the last class. Okay, now in intrinsic semiconductor we have holes and electrons, so the total will see, we call it as a carrier concentration. Okay, that we will derive this one. Okay, now just we will derive the carrier concentration in intrinsic semiconductor, that you can write Ni square. This is Ni means intrinsic, suffix I means intrinsic semiconductor, N means carrier concentration, that square is called N into P. N is the electron density, P is the hole density. We know these formulas also. Just you substitute here. If you substitute here, okay, then what is the N means NC exponential minus of EC minus EF by KT, and exponent for P you have to write NV into exponential minus of EF minus EV by KT, right? Okay.
Okay.
Now
Now
just okay. Please mute. Someone is unmuting. Okay. So you here you write NC into NV. Okay. Under root, or you can Ni is equal to, you can write this way, and here exponential. See simple formula here I am writing. Okay. E to the power of A and E to the power of B. What is the answer? E to the power of A plus B, right? And here we have a row, or you can write e to the power of a by 2 and e to the power of b by 2. Then answer is a plus b by 2. A plus b by 2. Okay. So here you can write exponential. I am square rooting out. Okay. Exponential EF plus EC. Okay. This term here, B term. Again, EF minus EF minus of minus plus EV by here. What is the in the denominator? 2 KT, right? 2 KT. Is it okay? Just I'm here square is there. I'm sending out right hand side. Okay, just that is the nothing I'm doing. Okay, just we are adding these terms. Okay, so here 2 into, or you can keep it like this way. At this moment you keep it like this. NC into NV under root exponentially here EF and this EF will be cancelled out, right? EF and so sorry here this one is minus, right? You see something is missing, right? EC minus EV. EC plus EV by NI is equal to something is it missing?
Minus, sir.
Minus EV minus EF. It is okay. Minus EC, right here? Nobody is saying, isn't it? Here, if you first term, if you see this term, yeah, but nobody is saying. That's why I'm confusing. So you take out minus EC and EV by 2. EV by 2 KT, right? EV by 2 KT. So here NC NV just I'm keeping as the substitute the place exponential. I'm taking out minus. So EC minus EV by 2 KT. EV by 2. Okay. From this expression, so EC minus EV what? What we can write? Somebody. So otherwise because everyone getting disturbance, so that you please understand that one. Okay. So here EC and EV. So this is EC, lowest energy of conduction band. This is EV, highest energy of valence band. The difference between these two energy levels, what we are calling the difference between these two levels. What is the difference between these two levels? Energy gap, isn't energy gap definition? What is the energy gap definition? The difference between EC to EV, right? The difference between two energy levels, lowest energy of conduction band, highest energy of valence band, isn't it? Okay, you forgot or okay? NC into NV under root exponential minus EG by 2 KT. EC minus EV we can write EG, right? Is it right or wrong?
Yes, sir.
So the energy gap definition from the definition EC, the difference between EC to EV we are calling energy gap. Okay, now this is the total carrier concentration in intrinsic semiconductor. Okay, intrinsic semiconductor. You can write this expression or you can substitute NC, NE, NV values that we will substitute it now. Okay, 2 into 2 pi MET. Okay, MEKT by H square to the 4 and or NV also you can write 2 pi M star KT by H square to the 4 of 3 by 2 and here square root is there. Okay, you can write square root here and exponential minus EG by 2 KT. EG by 2 KT. Okay, now if you simplify this expression, what will get? 2 into 2 pi KT by H square to the 4 of 3 by 2. Can we write outside of the integral? Sorry, square root, because here same term is there, here same term is there. One term we take out from the root. Okay, here ME 3 by 4 and MH 3 by 4, right? Here MH, ME is different. Okay, other remaining all are same. That's why we have taken out of the root, or you can simplify this way also. Okay, and exponential minus EG by 2 KT, EG by 2 KT. Okay, now we will further simplify this expression. Okay, Ni, that is intrinsic carrier concentration, and 2 into 2 pi KT by H square to the 4 of 3 by 2 and Me into Mh, okay, to the 4 of, we can write 3 by 4, isn't it? 3 by 4 can we write? a to the power of, suppose x to the power of a and x to the power of, we can write same. Okay. So here exponential minus Eg by 2 kT. Okay, Eg by 2 kT. This is the carrier concentration in intrinsic semiconductor. This term is common. K is the Boltzmann constant and T is the temperature and H is the Planck constant. Me, MH are the effective mass of hole, and E is the band gap. And see here in this expression, the intrinsic carrier concentration mainly depends on temperature. Okay, temperature, because see in intrinsic semiconductor what we are doing, so we are how we are increasing the conductivity in intrinsic semiconductor by increasing the temperature only. So here number of electron, the bound electrons are there, this they will jump into the conduction band. Here these electrons are free in the conduction band and these holes are free in the valence band. This way, if you increase temperature, more number of electrons in the valence band break the bonds and jump into the conduction band, then these electrons will be free for conduction. Okay, that's why the temperature will mainly affect the conductivity of intrinsic semiconductor. Okay, and also this Eg also affects, because if band gap is very high, you need to give more energy, more thermal energy. Then only electron overcome that band gap. Otherwise, it will not overcome. The electrons doesn't have that one. Even here, electrons break the wire in the valence. But if that electron doesn't have that much energy, they cannot jump into the conduction band. So, if smaller